This next example, again, we're going to analyze the graph of a hyperbola. This one, the equation doesn't look as nice as, if it was given to us with just x squared and y squared. Here I've got an x and a y term also, and so I've got some work to do. We're going to have to complete the square. This is going to end up being a shifted graph, and then we're going to have to, after completing the square, we're going to have to divide out by whatever the constant is on the other side to make sure we have a 1 over there. So, again, we want this, and I'm looking at this, I see that the y squared is positive and the x squared is negative. That gives me a pretty good clue as to how this is going to end up. It's probably going to end up in the form x minus k squared over a squared minus, I'm sorry, I said y, or I said x, but it's y minus k squared, and then x minus h squared over b squared equals 1. That's the format I want to put it in eventually, okay? So we're going to complete the square, we've got to do some algebra here to make that happen. So first thing I'm going to do is get rid of the constant. I want my constant over on the other side, and then I complete the two squares and divide out by the constant. So we'll add the 4 over, and then regroup the y's and the x's. So I want y squared minus 4y, then I want minus 4x squared minus 8x, and over on the other side I'm going to put the 4 because I'm going to add that to both sides. Now I'm leaving some space because I kind of know ahead as I complete the square I need that space. This first one here, to complete the square, I'm going to divide by 2. That gives me a negative 2, and then square that result, and that gives me a plus 4. That's a 4 to add on to the left side. I also then need to do the same thing to the other side. I'm going to add 4. Okay, so adding 4 to both sides. Now, with the other expression here, I actually need to factor out negative 4 before I can really proceed here. So I'm going to look at negative 4 times x squared minus 2x. And then I figure out what I need to do to complete the square on the inside, and then just multiply that by negative 4 before I put it on the other side. Okay, so on this one, let's see. I again need to cut this middle term in half, and that gives me a negative 1, and then when I square it, I'm going to get a plus 1. Of course, I'm not actually adding 1 on that side, I'm adding negative 4 times 1, which is negative 4. So if I add a negative 4 on that side, I better do the same to the other side to balance things out, okay? So that's how I would complete the square on that equation. Now, I need to factor each of those groupings. So the y's are going to factor into y minus 2 quantity squared. The x's here, I still have a minus 4 on the outside, and then this becomes an x minus 1 quantity squared, with both the negative 2 coming into the parentheses in the factored form, and in this case the negative 1. Does that look right? Yes, I think that's correct. Minus 2 minus 1. Just double checking everything, make sure my signs are right. When I was thinking this through beforehand, no, that's not right. I do have a mistake in there. I thought so. Something was not right. Something wasn't sitting right with me. When I pulled out this negative 4, that should be a plus 2, shouldn't it? And that plus 2 should make this a plus 1 and a, oop, I don't want to make that blue. Make this a plus 1. All right, now I feel better about that. Okay, I think that's appropriate now. So this is going to be a shift up 2 and left 1, if I'm seeing that correct. Okay, and on the other side, my plus and minus 4 is actually add up to 0, and I'm just left with that extra 4 over there. That kind of worked out well, actually. Unless I made a different mistake in there. No? I don't know. I think it's right. Anyway, now I want to divide out by this 4. So divide by 4, divide by 4, divide by 4. Those cancel. Those become 1. And what I'm going to be left with is y minus 2 all squared all over 4 minus x plus 1 squared all over 1, I guess. Those canceled out. I don't really need to write the 1 in there. Sometimes I like it just so I am aware of what the a and the b values are. And then on the other side I just have the 1. Okay, that's good. That tells me a lot of information right there. First of all, it tells me the center. The center is at 2 comma negative 1. No, other way around. Whoops. Can't make that mistake. Yuck. It's at negative 1 comma 2. Yes. X direction, that's the horizontal shift. Y direction, that's the vertical shift. Negative 1 comma 2, and you gotta change the signs. Okay, that makes sense now. Now also the positive is the y squared term. The positive term is the y squared, which means this is going to open vertically. Transverse axis is a vertical axis. Okay, the transverse axis in this case is going to be a vertical line running through the center, which is at negative 1. So I'd want x equals negative 1 for my transverse axis. The conjugate axis will be horizontal in this case. And that's going to be a horizontal line running through the center as well. That'd be y equals 2. Okay. I also have the a and b values. They're the square roots of these denominators respectively. So a is 2 and b is 1. That's going to help us out tremendously when finding the vertices and the foci and the oblique asymptotes. All right, and so actually let's go ahead and write the oblique asymptote formulas in there. Oops. For the oblique asymptotes, I know that the formula is going to be shifted according to the center. It's going to be y minus k equals plus or minus. Now remember, I'm doing this without looking at formulas because I just understand the relationships here. It's going to be the y over the x constants here. So it's going to be a over b times x minus h squared. Okay? Hopefully that makes sense to you. So it's always the y over the x, and then you shift by the h and the k, and when I put all that stuff in, it gives me the equations of my oblique asymptote. So I get y minus 2 equals plus or minus a over b times x plus 1. Oh, I don't want a square on that. This is a line, right? Not a parabola. Yeah, it's not squared. I'm still got my mind up on here, right? So that's the equation of the line. Now the a over b, why did I put a and b in there? That should actually be 2 over 1. Okay, and now if I were to, I could simplify this. I'm actually going to get 2 different equations, one with a plus and one with a minus, and I really should treat them differently. So I'm going to go ahead and do that. Let's do y minus 2 equals 2 times x plus 1, and let's do y minus 2 equals negative 2 times x plus 1. Okay, it's not just the slopes that will change here, the y-intercepts are also going to change when I distribute. This actually is the point slope form of a line. You might recognize that. Point slope form of a line is a shift, vertical and horizontal shift of a line. Anyway, y minus 2 equals 2x plus 2. When I add this 2 to both sides, I get y equals 2x plus 4. That's kind of nice. Over here, y minus 2 equals negative 2x minus 2. Add the 2 to both sides. The 2's all cancel out here. You get y equals just negative 2x. All right, so that gives me my slope-intercept form for each oblique asymptote. Okay, the only things left to find are the vertices and the foci. The vertices are going to be pretty quick to find. Vertex 1 is going to be, well, it's along the transverse axis, okay? So it's along this vertical line at -1. So I know the x coordinate has to be -1. It's the y coordinate that changes. And so for the y coordinate, you're going to take the y coordinate of the center, so you shift it to the center, and then you add from there and subtract from there the value of a, which is 2. So I'm going to start at 2, and I'm going to add 2, that gives me 4, and I'm going to subtract 2, that gives me 0. Okay? And so the first one, I'll go with the lower number, is -1 comma 0, and the second one is going to be -1 comma 4. Those are my two vertices. Now, the foci are the only thing left to find, and I can find the foci by solving for c. Remember, I need the equation b squared equals c squared minus a squared. And then, let's see, I plug in my b squared and a squared, which I know they're 1 and 4 respectively. So I have, let's see, 1 squared is 1, and 2 squared is 4. If I add the 4, I get a 5. And so c is going to equal the square root of 5, which is approximately, it's like 2.1 probably, roughly. Oh, 2.23, a little bit off, right? 2.24. Approximately 2.24. It's almost 2 1/4, all right? Okay, so that tells me that the focus then, focus 1 and focus 2, well, focus 1, I'll go with the lower value. They're going to be on the conjugate axis, which means that their y value is fixed at 2. So on both of these points, they're going to have a 2 in the y coordinate. The x coordinate then is going to be shifted. You start at the center, that's -1, and then you add and subtract the 2.24. So if I go with, the first one here, if I go -1 minus 2.24, that'd give me the first one. And then this would be -1 plus 2.24. The first one here is -3.24, and the second one would be 1.24. All right, so that gives me my two foci from those values. Okay, so now all I have left is to plot all this stuff and get a nice graph going. Now, the center is shifted, -1 comma 2. See if I can get a decent looking graph here. Okay, so I got to go left 1 and up 2. Probably built more of this down than I needed. And I probably need more going up, honestly. So maybe I'll extend that up a little bit. All right, and now, so from the center point, best thing to do is just to draw the box in, okay? So I could plot all the points, but let's go with the box first. The box goes in the y direction up and down 2 from the center, and in the x direction left and right 1. So up and down 2, that puts us at 4 and at 0. And left and right 1, that puts us at 0 and at -2. Oh, that's not really very vertical. Let's get that in nicely. Okay, so there's my box, and then I connect the diagonals. I could also think of it using my slopes here. A -2x going through the origin would connect the corners. Trying to get that roughly straight. That's not too bad. And then the 2x plus 4, it's going to be a +2 slope, and it intersects at 4 on the y-axis. So this actually is all coming together very nicely. Perfect. Okay. Cool, now I need to plot my points. I know that this is going to be opening in the vertical direction. And so my vertices are at -1, 0 and at -1, 4. Those 2 points. My foci are at negative. Did I do that wrong? I indeed did that wrong. Why did I go along the conjugate axis for the foci? That makes no sense. I should not have done that. Edit, erase, pretend that didn't happen. It's in the video, I ain't pulling it out now. This is not correct. Oh my goodness. Oh, and that's going to be on YouTube for the whole world to see. Oh well. Anyway, so that is not correct. I totally did that on the conjugate axis. The foci are still on the transverse axis. I don't know what I'm thinking on that one. See, it's nice to have the picture there, right? I got to think this through visually. So I do need to stay on the transverse axis. And so from the center, which is up at, let's see, up at 2, I fixed the x value at -1. All right. Then you start at 2, and from there you go up and down a value of 2.24. I don't know what I was thinking on that one. So from 2, I go up 2.24. Yeah, and that should put you on the inside there, which is 4.24. Oh, I want that to go down. That one's going to be the lower one. So let's do the bigger one as 4.24. And let's do focus 1 as the difference. So I'm going to start at 2 and drop 2.24. That'll put me at -0.24. Okay, that looks better. That gives me my foci right about there. And right about there. Okay, a quarter of the way up to the next unit. Okay, that looks way better. And then my graph needs to just hug those asymptotes all the way up and all the way down. All right. Not too bad. Hopefully that made sense once I made the adjustment on the foci there. Everything else came together very nicely on this one. Don't make the same mistake. Hopefully you've learned from my mistake. Both your vertices and your foci all line up on the transverse axis, not the conjugate axis. The conjugate axis is the other horizontal axis of symmetry for this one, which I didn't actually plot either the transverse or the conjugate axis, but you could plot the vertical and the horizontal lines correspondingly there.